Welcome to European Aerosol Conference audience. My name is Pietro Morozzi and I'm a PhD student from the Department of Chemistry Giacomo Ciamician at the University of Bologna. My goal today is to quickly present you the potential use of non-destructive spectroscopic techniques and multivariate statistics for the analysis of atmospheric aerosol collected on membranes. Briefly, I summarized the relevant achievements by ultraviolet visible diffuse reflectance spectroscopy on the left and Fourier transform infrared spectroscopy on the right. Both techniques allow analyzing directly particulate matter filters without any chemical preparation and in a short time, less than 1 minute for a single sample. This non-destructive analysis permits to obtain spectra that can be subjected to multivariate statistical analysis techniques to provide information about the atmospheric aerosol emission sources. The examples shown in the following slides are derived from hundreds of daily particulate matter samples with Teflon support collected simultaneously at the two Spanish stations of Sierra Nevada and Granada as part of the FRESA project. The two sampling sites define respectively an urban environment, Granada, and a remote environment not significantly subject to anthropogenic activities, but strongly impacted by Saharan dust events, that is Sierra Nevada. In this slide, I present you the color of the analyzed FRESA filters in the three-dimensional scatter plot defined by the colorimetric space CIELAB. You can see how the color of the samples strongly depends on the sampling station, and cluster analysis on the reflectance spectra can be useful for defining a class of samples with similar colors that can be associated with specific peculiar emission sources. The color of the Sierra Nevada filters gradually changes from white to red, associated with increasing mineral dust component. Instead, the color of the Granada filters gradually changes from gray to black, associated with increasing organic matter component, partly due to the biomass burning in the winter period. Infrared analysis in transmission mode is another atypical analytical technique for particulate matter membrane and allows to obtain fingerprints of the IR active functional groups. The processing of the IR spectra can be performed by the IRSpec platform for the removal of the signal due to the Teflon support. Then the application of source apportionment by positive matrix factorization on treated spectra may provide reliable qualitative and quantitative information on ambient aerosol sources. In the present case study, this method can solve three emission sources, factors 1 and 2 that are linked with anthropogenic emissions from biomass combustion and urban traffic respectively, and factor 3 that is associated with mineral dust transport. The validation of the outcomes obtained by these innovative techniques with the results obtained by the traditional chemical speciation is extremely auspicious. For the ultraviolet visible diffuse reflectance spectroscopy, you can see the box plots of the biomass burning and mineral dust contributions obtained by PMF on chemical data according to the color-based clusters shown in the previous slide. It is confirmed as the color of the particulate matter filters agrees with the relative emission sources. Instead, for the infrared analysis, you can see the 2018 time plot of the mineral dust contributions obtained from the PMF of IR spectra in orange and of chemical data in blue, respectively. The overlap is almost identical, demonstrating the good ability of IR spectroscopy to correctly quantify the mineral dust source of atmospheric aerosol. This shows how these quick and non-destructive methodologies can support and integrate the gold standard analytical approaches in atmospheric aerosol science. Thank you for your attention.